For a project I'm doing, I need to make a boost converter which can boost up to something like 100 volts. So I've got a start on it here, and I'm using a crystal oscillator which I made in a previous video, just a few videos back. I'm using a 4 megahertz crystal here just to drive my boost control circuit. At the minute I've got the power taken off. I'm using a battery, being careful not to short it out. So it's a 18650, 3.7 volts power going into the circuit. And this PP3 battery over the back is just to drive my crystal oscillator because it's a module circuit which is separate at the minute. I've got an inductor down here which is a ferrite bead just with a bunch of turns around it. I'm not sure what the inductance value of that is. And this is my simple boost circuit. I've got 3 germanium diodes, which I'll explain on the circuit diagram later how it's constructed. A very cheap NPN transistor, BC337, which is like less than 10p to buy. I've got a 1k resistor feeding into the base of that from the crystal oscillator. I've got a little LED around the back to show when power's coming out, and a voltmeter connected to the output of the circuit. So if I plug in the battery, so that's 3.7 volts going in. In fact, I'll disconnect the crystal oscillator for now. So at the minute, I've got 3.7 volts going in and about 3.5 volts coming out. I think actually in reality, I've got about more like 4 volts going in, 3.5 volts coming out. And so in this crystal oscillator, so on these pins down the side here, I've got the 4 megahertz at the top and then divided by 2 each time for each set of pins. So I've got 4 megahertz, 2 megahertz, the 1 megahertz, 512 kilohertz, 256 kilohertz, which is the optimum one. So I'll just connect to the 256 kilohertz. So you see the LED got a lot brighter, and now I've got about 40 volts coming out of the circuit. So the 3.7 volts, maybe closer to 4 volts, is being boosted to about 40 volts with this circuit. And if I move down from 256 kilohertz down to 128 kilohertz, you see the voltage goes down from 40 to about 18. And if I go down to about 64 kilohertz, down to about 10 volts. But if I go 4 megahertz to 512 kilohertz, and you see it's going over the top of what the circuit's capable of because it's starting to drop down. So I'll go back to 256 kilohertz, which seems to be optimum for this circuit at the minute. And it produces about 45 volts when it settles down. So that's reasonably stable. So that's a good start to my boost converter circuit, and I'm hoping to actually improve on this circuit and make a much higher voltage output so that I can drive something around about 100 volts. So this is the boost controller circuit which I've got. So I've got the battery over here which supplies the circuit, and I'll go for a germanium diode because before it goes into the inductor, I don't want any back EMF from the inductor getting back to the battery. It's probably not essential, but I've put that in there just for safety. And then it comes down through the inductor to the switching transistor, which is just a standard boost converter circuit, and that transistor is fed from the 256 kilohertz crystal oscillator through a 1k resistor. And the BC337 is actually being driven to its maximum because I was getting an output of 45 volts, and that is actually the maximum that the BC337 can take. And the output comes through another germanium diode to prevent any charge from the capacitor, so it charges up the capacitor with the output voltage and prevent any the current going back and shorting down to ground. I've got the blocking diode there, so the volts come out to the output there. Also in the return circuit, I've got another germanium diode. That's not essential at all, I don't think. I think you could take that out, but I've got it in there just as a kind of an isolating kind of diode, and that just goes back to ground. Everything's common on that ground. So that's the basic circuit. It's not complicated, and getting very good results at the minute. I really need to double the voltage, so I've got some ideas on how to improve the voltage output of the circuit which I'll try out, and also the crystal oscillator input. I'm probably going to ultimately change that to be a PIC microcontroller or something, so I control the pulse width of the actual signal, and that should hopefully improve the efficiency as well if I experiment with some different pulse widths on the signal.